memory. Okay, so here the long short term memory also like a RNN node only. This is a node 1, this is a node 1, okay, and this is a node 2, and this is a node 3. Like that, we are having the n number of nodes are there. Each node performs different types of operations. That operations are very, very important. Okay, so now we'll see in detail. Okay, so here in the LSTM, there are two states are there. The first state is called as a shell state. Shell state. That shell state is called as a which retains the long-term memory, long-term information. I will explain the in detail once again. Okay, now shell state. There are two states are there. One is a shell state and a hidden state. The shell state carries the long-term information. That means the first word of your message, first word of the content to the last word of your data set. So that is the purpose of the shell state. And the second state is there, that is called as a hidden state. Hidden state carries the only short-term memory. Okay, now only short-term information. That means it carries only previous node information only. It does not carry the long-term information. Whereas the shell state carries the long-term information, whereas the present hidden state carries the previous node information. So that's why this is called as a long-term and short-term information. Okay, simply it is called as a LSTM. L means long term, S means short term. L nothing but you have to read you have to maintain the information from the present first node information to the last node information, whereas S means short means only it carries the previous node information only, whether it is important or not. Okay, now so based on these two states, we are going to get the one new state, that is called as a long short term memory shell. This is a shell is there, long short term memory shell that carries the both things. One is a long term memory and as well as a short term memory. Okay, now this is the way you have to carry. So one is a short long term memory. Okay, for the your input node, your node. Okay, and also you have to, based on the your previous node information, we are going to generate the new words. Two nodes you have to two outputs are going to generate. That is a CT and a HT. Okay, we will see the procedure later. Okay, now see this one here. In the for example, there is some sentences there. Okay, sentence like one paragraph is there. I like to travel and I visited Paris last year as a part of my business like that. Okay, there is some sentence are there. So here the important keywords are there, like Paris is one word is there, and Eiffel Tower is one word is there, and Cairo is the one word is there, and okay, and pyramids are the some keywords are there. So now I want to generate a new sentence. Okay, to summarize this paragraph, one or two lines. Okay, here a lot of words are there, a number of sentences are there, a number of lines are there. Okay, I want to summarize this message in a shorter term. Okay, so in order to avoid that, in order to summarize this one, you have to you have to read you have to maintain some important words from the first word to last word. Okay, with the help of shell state, we have to maintain the long-term information. We have to maintain the long-term information. With the help of hidden state, we have to maintain the short-term information. Short-term information. So here, with the help of shell state and with the help of hidden state, we are going to generate the summarize the keywords here. Okay, summarize the entire paragraph into two lines. Okay, or one line. So I saw Eiffel Tower. So Eiffel Tower, okay, Eiffel Tower is there, and Paris there. Both are the you have to here is major keywords are there. Okay, you are maintaining the things. The Paris here to the first line. Okay, first line in the our paragraph, and Eiffel Tower here to fourth line of the paragraph, and also pyramids also in the last line of the paragraph, and Cairo in the fourth line of paragraph. Okay, now we are generating we are keeping the major keywords in our paragraph. Okay, with the help of our shell state, that is with the help of long term information, and also we have to maintain you have to remove the unnecessary information. okay, which is not important for our things with help of hidden state. Okay, so this is the way we have to apply in the LSTM. Okay, now in the LSTM we are going to have the two things are there. There are different gates are going to use in the LSTM. Those gates are called as a forget gate, input gate, and output gate. There are three gates are there. One is a input forget gate, input gate, and output gate. These three gates are very important. Okay, so here this is your node, LSTM node. This LSTM node, for this LSTM node we are giving the cell state and hidden state. We are going to get the output also cell state and hidden state information, but in the internally it perform the three operations. One is a forget get operation, input get operation, and output get operation. These three important operations are performed in a single node. One single node, one single LSTM node that perform the three operations. Okay, now the first thing is called as a forget gate. Forget gate. Okay, this is called as a forget gate, and then it is called as your input gate. We will see in detail. Just wait. This is your forget gate, and this is your forget gate, and this is your input gate, and this is your output gate. Okay, output gate. So total after that we are going to get the output as a CT and HT as a output, and CT minus 1 as the CT minus 1 and HT minus 1 and the present state are the input for your model. So we are going to see how it works. Okay, now. And now here the for example here CT minus 1 is there. Okay, CT minus 1 that is carry the long-term information. Long-term information. This is some words are there. That means I visited Paris like that. So some long-term information is there. That word is there. Okay, some this is one set of words are there. Okay, or it in the form of a we are converting that entire word into word to vec. Okay, and here previous words also are there, and then the present word is there. That present word also converted into vector. Okay, then after that what happened? We are performing the okay. We are concatenating the HT word, okay, and HT minus 1 word, and then we are going to be we are concatenated the HT minus 1, nothing your previous state hidden information and the present state input value. We are going to be concatenated, and that is multiplied to our output weight value, weight of the forget gate. Okay, weight of the forget gate, and that is added to bias term value. Okay, bias of the forget gate. After that, whatever the word is there, that is given to sigma. The sigma values are there now. That's if based on the present word, for example, based on present word, okay, if it is important or not, or we have to identify. Okay, based on present word information, we are going to get the output between the 0 to 1. For example, if the present word is an important word, then okay, if it is an important word, then if it's not important word, based on the input output values of the sigma value, whether it is 0 or 1. If it is an important word, okay, then what are the information is in the CT minus 1, that is multiplied to present FT value. Okay, that is then we are going to get the output as a CT minus 1. Okay, now that means if it is an important word, that is a CT minus 1 is multiply with to FT. What the FT value? Either it is a 0 or 1, or between the 0 to 1 value. So that value is going to be multiplied to CT minus 1 is multiplied to okay FT value. So that much of information is going to be forgotten from the long-term memory, and the remaining information is going to be carried forward to the next layer as input value. So that is called as a CT. Okay, now that is called as a CT. CT nothing but a okay. How much amount of information is going to be forget with the help of sigma value. Yeah, okay. CT minus 1 is multiplied to FT, that much of information carry forward to next layer as input. Okay, that is the purpose of the forget gate. Now, so here, this is also not required. Okay, and then after that, we are having the input is there now. That is a CT. Okay, and then whatever the previous node input gate is there, input gate. Okay, Now present word is a very whether it is a important word or not. If it is added to the current state or not, we have to identify. So we are having the present state information. Present information is there. That is a HT minus HT, and the previous node information is there. That is also in the sum of word. Okay, both are going to be concatenated. Okay, both are going to be concatenated, and then you have to apply you have to multiply it to our weight value, weight of the present node input value. Both are going to be concatenated and apply multiply the weight of the input value, and then we have to add the bias term. After that, we have to given the input the sigma value. Okay, it means input to input. Okay, whether the present input word is very important or not, you have to identify. Okay, if it is important word, that important word is going to be added to the long term memory. If it is not important, if it is okay, simply are going to we are not added to the present word is not added to the long term memory. If it is important word, it is added to long term memory. Okay, to maintain the long term information. Okay, now so now what are the output of the sigma value? It becomes between the 0 to 1 only. Okay, if it is a 0, we are not adding the present information to the um, uh, present information to the IT value. Okay, if it is a 1, then that means the present input value is a very important word. Then we are going to add it to the corresponding IT value. Okay, it is equal to 1. Okay, if it is 1, we are going to add it to the our value same long-term memory. If it is not, if it is 0, we are not added to the things. Then at the same time, we are going to same operation going to be carry forward to the here also. We are going to concatenate the HT minus 1 with XT, and then we have to multiply the weight of the present node weight. Okay, WC. Okay, WC, and then we have to add the bias term in current node. Okay, current cell, and then we have to apply the tan h value. The tan h value between the minus 1 to plus 1 value. Okay, now so if it is a 1, if it is a 1, if suppose if it is also 1, or if it is also CT theta also 1, then both are the very that means the output is also 1. For example, both are the 1. 1 into 1 means 1 only. So that means the present word is going to be very important. That word is going to be added to the long term memory, that maintains the long term memory. Okay, now that is the purpose of the CT minus that input gate. So based on the present node and based on the sigma value, based on the tan h value, we are going to add the present word, okay, to the our long term memory. Whether you have to remove the from the long term memory or not. Okay, that is depends on the our sigma and tan h values. Okay, then after that, after the applying the forget gate, after applying the input gate, then we have to apply the concept called as a or what we call that forget output gate. So see this one example here in the I like to Paris. Paris, the present code is nothing but a Paris. So Paris is not in the long term memory. We are reading the long term memory. Okay. So Paris is a, you have to identify whether it is an important word or not. If now it is an important keyword. Now so that important keyword is added to the our long term memory. Okay, now with the help of our input gate, with the help of sigma activation function and tan h activation function, we are going to add the Paris word into the our long-term memory. So in the previous cases, what happened now? I like to. These are the not important words. So these are not added to the our long-term memory. Okay, now long-term memory. Okay. So for example, here Eiffel Tower is there. Eiffel Tower also very very important. That Eiffel Tower also added to the our long-term memory with the help of we are carrying the Paris from the previous nodes, and also we are adding the ET nothing but Eiffel Tower. So with the help of input gate, okay. In the input gate, there are two operations we are performing. One is a sigma operation and tan h operation. Both are going to multiply. Okay, if it is a 1, that is added to the long-term memory. Otherwise, we are not adding. Okay. So see this one in the previous case also. Okay, in the mm, okay. Now see like that we are going to get the out. We are adding the inputs, and then finally we are going to get the output gate. What output gate here? The output gate is nothing but a based on the present state information, based on the present state information, based on the previous state information, we are going to be added to the here. Okay, we are going to get the added, and that is going to be multiplied to weight values. After that, we are going to get the sigma value. The sigma may be a 0 or 1, 0 or 1. Okay, 0 to 1. Okay, if it is 1, that is multiplied with whatever the long information is there na ct. Okay, that ct is given to tan h value. Tan h value, what the tan h value, it becomes -1 to +1, -1 to +1. So ct is going to be multiplied to that tan h value. Okay, that is c is one here. ot, what the ot value? Ot nothing but a ht minus 1 is added to the xt. Okay, that means present node information is added to the previous state information, and then we are going to multiply the output of the output weight of the output value, and also we are adding the bias term. Then we are going to give the input to the this information to the sigma function. Okay, sigma is going to generate the values between the 0 to 1 values. Okay, then we are going to get the ht value. How can you get the ht value? With the help of whatever the information is there now, with the help of forget gate. After applying the forget gate, after applying the input gate, we are getting the some ct value. That ct value is given to tan h value, tan h of ct. What are the tan h value of ct? That becomes -1 to +1. Okay, now, so already you know the values of ot, that is 0 or 1. Okay, now, so we are going to be multiply these two things. We are going to get the new weight value. Okay, new value, that is called as a ht. Okay, that ht carry forward to the next layer as a input value. Next layer as a input for the next neuron. And at the same time, whatever they added to the previous node in the hidden input for after applying the input gate, what are the information is carried in the long-term memory, that is carried forward to the next layer as a input value. So like that, all the three gates are going to be worked out in the our LSTM. So that is about the LSTM. So here there are three gates are there in the LSTM. In all the three gates, there are four weights are there. There are four weights are there. In the first weight, okay, in the first gate, in the forget gate, we are having the only weight of the forget gate, and also in the input gate we are having the two weights are there. One is weight wi and wc, and the output gate we are having the one weight is there, that is called as a w naught. Suppose if you are having the last function is there, at that time you have to update these four weights also. Okay, these are four weights, and we have to perform the back propagation and apply new weight values, modify the weight values, and once again you have to apply forward propagation. Like that, you have to apply the things. Okay, simply this is the way you have to implement your long-term memory LSTM and GRUs. GRU also like similar to this only, but here in the LSTM we are having the three gates are there now. One is forget gate, input gate, and output gate. But whereas in GRU we are having only two gates are there. That is update gate and forget gate. Like that we are having the two gates only. Okay, in GRUs. But in the most of the cases, LSTM is going to be used in most of the real-time applications. We are not rarely RNN and GRS are going to use it in the real-time applications. Most of the cases, the LSTM are going to use it in the real-time applications. Okay, now. So what the difference between the LSTM and the RNN? Nothing but for only small text messages, we are going to use the RNN. But whereas for the LSTM, it is a large data set is a large data set, or okay, the data set contain more information is there. At that time, you go for the LSTM. So this is about the implementation theory behind the both RNN and the LSTM.